Hey Algebra 2 friends, we're going to be solving equations algebraically, systems of equations. We're in section 3.2. Let's take a look at a couple of methods that we will talk about today. So the last chapter we remember, or last section rather, you remember that we were graphing and we were finding the intersection point, and that would be the solution. And here, the substitution method, you probably remember having a situation similar to this where y is solved for or easily solved for, some one of the variables, x or y is easily solved for. And what you do is you take this value of y, let me make this a little bigger, you take this value of y and you're going to put it into the equation here. So what this would look like when you combine the two equations is you get x plus, instead of having y, you're going to have 2x plus 3 is equal to 6. And we know that we can solve this pretty easily because solving with one variable when it's a linear equation we are so good at, right? And so now I get that x is equal to 1. Cool. But the key to this is, remember, you're not done. You're going to plug that 1 right back into the equation. Either equation will do. And when you plug it in, you get 1 plus y equals 6, or subtracting 1 on both sides, you get that y is equal to 5. Just to make you happy, I'm going to plug the 1 in here and show that we get the same thing. If I put the 1 in for x into this equation, I get 2 times 1 plus 3 is 5, and that is exactly what y is. And so substitution was that method. I'm going to erase this because it just got sloppy, and I want to show you the next method. So elimination is a little bit is useful as well, and it can simplify life, particularly when you have coefficients around your x and y variables. So take a look at this. If I have two systems, or in a system of equations where the two variables in them are all hanging out with a coefficient, right? The coefficient is the number multiplied next to a variable. If that's the case, this is a little bit more challenging to do substitution method. You got to work it out a little bit more, and you might potentially be substituting fractions. So what we realize is that if we can make the coefficients of two variables of the same variable opposites, then we can just add the whole thing up together. So I like to make them additive inverses. Some teacher talks about subtracting. That's okay. That's not how I look at it. So if I had this and I'm going to make them additive inverses, when I add 2x plus a negative 2x, I get 0x, which makes me happy. It's just 0, really, which makes me happy because I've lost a variable, and now I can concentrate on what I have here. So then I'm going to continue through with my addition process. 3 plus 5 is going to give me 8y. And then 17 plus, this is supposed to be negative 19, it's going to give me a negative 2. And then I can solve for y quite easily. So I get y is equal to negative 1/4. The next thing I'm going to do is take this y value and I'm going to chuck it into either equation that makes me happy. I'm just going to do the first one just to say we completed the problem. So 3 times negative 1/4. That's going to give me 17 when I add that to 2x. And so now I'm going to have to do some multiplication. Oh no, why did she choose fractions? Because she's a crazy lady. All right, don't say that. That's really mean. All right, so we're going to add 3/4 to both sides. And because this is a fraction and all of that stuff, I'm going to change 17 to a fraction and say that 2x is equal to, let's see, 17 times 4 is 68. So this is 68 plus 3, right? You guys with me? You see what I'm doing? And then so we get 2x is equal to 71/4. But then I don't want to, I'm just all over the world here, people. Stay with me. 2x is equal to 71/4. I got to get rid of that 2 by dividing both sides by 2. Or I could look at that as by multiplying both sides by 1/2. You see what I'm doing here. X is therefore equal to 71/8. All right, and I don't mind the improper fraction. You know, technically I don't generally do these little decimal type problems with the big old fraction situation, so you can feel a little confident, but hey, we're big time in it. We're good. And could you imagine graphing this, right? If you had to graph this whole thing and look for 71/8, which is like really close to 9 but not, and then determine that, it would be tragic. So they told us to solve this one by substitution. So whenever I have to do that, I'm just going to look for a variable that looks like it's hanging out by itself. X looks alone and positive. Y is alone but is negative, and I'm trying to do as little work as possible, my friends. So since x is positive, I'm going to get rid of everything else on the other side, rewriting this equation as x is equal to negative 2y plus 8. Are you guys with me? I hope that made sense. And now I'm going to leave this equation as it is, but I'm going to replace the x with this value here, minus 2y plus 8. So notice I left a little blank here. I'm going to put my minus 2y plus 8 there. Are you guys with me? All right. So now that I do that, this doesn't look really pretty. Let me rewrite that. There, that's better. So I have my equation in one variable. This time it's y. I'm going to distribute to solve. So when I distribute negative 1/2, I get a positive y here, and then I get a negative 4 minus y is equal to 18. As I look at this, I realize this is not negative. I don't know why I made that happen. I think that might have been a stray mark. So I'm going to do this again with my distributive property. 1/2 times negative 2y is going to give me a negative y. 1/2 times that, 8 will give me 4. And then I'm going to subtract y. That's equal to 18. Joining those like terms together, I get a negative 2y plus 4 is equal to 18. Move that 4 over to the other side. When I do that, I get negative 2y is equal to 18 plus a negative 4 is a positive 14. Divide both sides by negative 2. Y is equal to negative 7. Am I done? No, not quite. I need to now take this value and plug it back into any one of these equations in order to solve for x. And since this is already solved for x, I'm going to use this one. So x is equal to negative 2 times negative 7 plus 8. You see where I'm going? And now negative 2 times negative 7 is 14. 14 plus 8 is going to give me 22. Yeah? Yeah. So x is equal to 22 when y is equal to negative 7. And you can mentally plug these in and confirm the answer for yourself, because remember, the x and y answers that you get needs to work for both equations. All right, so here we have a type of problem that we used to have on the SATs way back in my day. They were called quantitative comparisons, hence the name. And so quantitative comparisons gave you 3 choices. You're basically comparing 2 things. Sometimes you have to solve, but the answer choice A is going to be that the thing in A column is greater. The answer choice B says the thing in B column is greater. The answer choice C says the 2 quantities are equal. And the other one says that the relationship D is a relationship cannot be determined from the given information. So we know that we can determine this information from this given situation. So we can solve this. And I feel like we can solve it using substitution if you'd like. So just because that's what we've been talking about. So I'm going to solve for x. I don't know why I did that. I just decided to, just because I was writing. So now I solve for x, right? X here is this. I'm going to replace this x with this value here. And when I do so, I get that 2 times 13 minus 3y plus y is equal to 11. Distribute this whole thing. I get 26 minus 6y plus y is equal to 11. Joining like terms together, you guys see what I'm doing? You see me? You see me, chaplitos? So we subtract 26 on both sides, and then we end up with negative 5y is equal to 15, right? And then we divide, negative 15, sorry. I know, I heard you, I'm sorry about that. And y is equal to a positive 3 when I divide both sides by that. So y is equal to 3. X is equal to, let's see, is there some quick way we can do this? Well, I can plug in 3 here, and if I have 3 and I subtract 3 from 11, I'm going to get 8. So 2x plus 3 is equal to 8. 2x plus 3 is equal to 11, which means 2x is equal to 8, which means x is equal to 4. All right? And so now the answers are not equal. We realize that this guy is the answer. The answer in column A is greater than the answer in column B. Let's go ahead and use elimination. Elimination, remember, we want to make sure that the 2 coefficients that are over top of each other, we generally want to line up things so that the variables are on top of each other. The 2 coefficients that are over top of each other are additive inverses. And the easiest thing to make an additive inverse would be B, so I'm going to eliminate B by multiplying both sides of the first equation by negative 1. I'm going to do a rewrite. I get negative 4a minus 2b is equal to a negative 15. That's that -1 doing its thing. And then I rewrite the second equation exactly as I had it. Now I'm going to add everything together, and beautifully enough, the a term is there, -2a, but the b term goes away. So -15 plus 7 gives me 8. So rather, it gives me -8. When I divide both sides by -2, I get that a is equal to a +4. Now, you guys don't know this, but I did this whole problem with the wrong answer, and bad things happen. So you do want to make sure that you're doing the thing correctly. So -8 divided by -2 gives me a +4. I need to now solve for b, plug it into either equation. I'm going to do this lower one first. So I'm plugging a value as 4 into that, and I get that 2b is equal to 7. I don't know where that 8 came from, children. So 8 plus 2b equals 7. Subtract 8 from both sides. I get that 2b is equal to -1, and therefore b is equal to -1/2. And I'm going to check this because I just needed to from last time. So 4 times 4, right? What I'm doing is I'm putting 4 in for a and -1/2 in for b. 4 times 4 plus 2 times -1/2 is equal to 15. Let's see how that works. 16 plus 1, -1 equals 15. That's Coolio Patchoulio. Let's check this second equation, which should work because we just used it, but I'll do it anyway. Put a 4 there plus 2 times -1/2. And let's see if we get a 7. 8 plus -1 is 7. And now I feel comfortable. As I said before, checking is mad helpful. All right, so we're going to use elimination here, but this time this elimination situation requires us to multiply. I'm going to rewrite for ease. Okay, now that that's rewritten, the thing you have to do in a problem like this is you just need to decide which variable you want to get rid of and then do the thing you need to do to get rid of it. So for me, I don't know, I'm liking getting rid of the y for some reason because the signs are already different. And so I'm going to do that. And so what I need to do is multiply both equations by numbers that's going to make the coefficient of y additive inverses. And I'm going to multiply this equation by 2 on both sides and this one by 7. When I do that, it's going to look like this. So I get this, all right? And so let me diminish the equations that we don't need so I can focus on the ones that we are going to use, all right? So we have these guys. Now we're going to do what we've done before. We're going to add them together and get rid of the y term. So when I add these guys together, I get 41x. The y's go away. And then together I get, this is a -28. So let me do some subtraction. So with that subtraction, I get 287. And I'm not going to lie, I pulled out a calculator. Okay, people? I did. Not for the subtraction, but for this part. And I got x is equal to 7 because 287 divided by 41 is 7. I guess I could have seen that here, but you know, my brain was saying no to the work. So my answer to this is x is equal to 7, but wait, there's more. We need to figure out what y value is. And so I'm going to plug in my 7. 3 times 7 minus 7 times y equals a -14. I get a 21 minus 7y equals -14. And then over here, -7y, subtracting 21 on both sides, I get a -35. You guys are with me. I know you are. I'm not moving too fast for you. Y is equal to 5. So that's my answer. 7's equal to x. X is 7 and y is 5. We could plug it into the next equation to check it out. 5 times 7 is 35. 2 times 5 is 10. 35 plus 10 is 45. And I'm feeling good about myself. All right. Now that we've done this, I want you to do the example problems or the questions that you have if you didn't get around to doing them before. Please take care. Let me know if there's anything I can explain better. There's more ways to solve systems of linear equations, and we'll talk about them soon. Take care.